Hey there everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be revising reactions of alkenes. This is for the organic chemistry module for GCSE chemistry students. So if you do enjoy the video and you find it useful, please do give it a thumbs up, share this with someone else so they don't miss out on key revision, and also subscribe if you haven't already. Thank you so much for your support. As I'm filming this, I have checked and it is officially 70 days until paper 2 chemistry exam for everyone in the UK. So if you are studying your exams in 2024 and you're preparing for them, very best of luck. I hope your revision is going well. If you would like any specific support or help, check out my channel and my Instagram and TikTok. Everything is at the GCSE Science Teacher, or feel free to drop a comment in the comment section below if there are any key ideas or revision tips that you would like me to cover, or even just any content as well. I'm more than happy to do that. So let's get started with no further ado. Reactions of alkenes then. So there's a couple of different reactions that you need to be aware of. The first one is a combustion reaction. We've already talked about combustion reactions, but just as a bit of a recap, remember that combustion reactions are essentially a reaction where you burn something, whether in a plentiful supply of oxygen, that would be complete combustion, or if there is not much oxygen present, and that would be incomplete combustion. Both of those types of reactions actually produce different products depending on whether there's a lot or not much oxygen. But in the case of reacting with alkenes, it's actually incomplete combustion, which means that there's actually a smoky flame that forms. And this therefore means that they're not particularly good as fuels compared to other hydrocarbons like alkanes. The other type of reaction you need to be aware of is called the addition reaction. And this essentially is what we're going to focus a bit more on today. And this is where one molecule essentially combines with another molecule to form a larger molecule. And there's no other products that form. Unlike in combustion, where there's multiple products, say carbon dioxide, water, carbon soot, that kind of thing, lots of different products are formed. In addition reactions, you just simply combine them together to make something much bigger. The reason there are even addition reactions with alkenes is because of the double bond that's formed between the two carbon atoms. Remember, alkanes, they only have a single carbon bond, which means that they can't actually undergo addition reactions. So it's very special for the alkenes because of that double bond there. So the first type of addition reaction that you need to know is called the hydrogenation reaction. Hydrogenation, as the word may suggest, contains hydrogen in it. And essentially what you're doing is you're combining alkenes with hydrogen, chemically reacting them together in the presence of a catalyst to form an alkane. And what's happening is essentially that double bond that's in the alkene breaks to form covalent single bonds with the hydrogen to form that alkane. So in the example here, we have butene, which is the alkene. It reacts with hydrogen. Hydrogen is a diatomic molecule, so it contains two atoms, and you can see that they are covalently bonded together because they're non-metals. They will form the butane molecule, and as you can see, there is no longer a double bond that is present. It's really important as well, if you are drawing out the displayed formula like this and you're showing the structure, you can condense it like I have and do CH3 for the other chains of carbon, or you can draw out all the hydrogens as well. It's totally up to you. Unless they ask you to do that, I would recommend you draw out the whole thing. This is just to keep it simplified so you can see the key things that are going on in this video. The other thing I will say is, if you are stuck and you're not sure how many bonds to form, remember carbon can only make 4 covalent bonds. So if there's already a double bond with the carbon, you know it only has 2 more bonds to make. However, in the case of the alkane, you can see that there are 4 bonds coming off of each carbon atom there as well. So here's an example for you to have a go at. What do you think the answer is? Comment down below. And of course, as always, there will be the solution in the description box. So do have a go. I'd love to hear from you. The next type of addition reaction is called hydration, and as the word hydration may imply, there is some water that is reacting here with the alkene. So alkenes and water form an alcohol. So kind of ironic because alcohol is actually dehydrating, but when you add water to an alkene, it's actually hydrating. But here we are. There we go. So what do we have to do? Well, the example we can see here is propane. Propane suggests there's 3 carbons. As you can see here, there's the double bond, so it's an alkene, and we've got 3 carbons in its structure. It reacts with water. Remember, water, the symbol for water is H2O, so there's 2 hydrogens and 1 oxygen. It is also reacting with the presence of a catalyst. Remember, a catalyst increases the rate of reaction, it isn't used up, and it lowers the activation energy. In biology, enzymes are an example of biological catalysts. And also we have a very high temperature, so 300 degrees Celsius. This is used to actually increase the frequency of collisions between the water molecule and the propane so that they combine much quicker. And when this happens, we get a molecule called propanol. And propanol, the OL, the suffix at the end, tells you that it's an alcohol as well. So just be aware of that. And you can actually see the alcohol functional group in this formula. You can see the OH group that tells you that it's an alcohol. So one thing I would say, especially if you're looking to do A levels as well, being aware of functional groups and what they look like is a really great skill to have. So I would recommend you make some flashcards on some of the functional groups that you've learned in GCSE chemistry, because if you are especially looking to do A level chemistry as well, you can always use those flashcards in your next few years as well. So definitely keep an eye out for the functional groups. Here's another example for you. Have a go at it. The solution, of course, is in the description box. So this is the final type of reaction that you need to be aware of for GCSE when you look at alkenes reacting with something. And what we're doing in this case is we're reacting an alkene with a halogen to form a haloalkane. Often it can be called halogen alkanes as well. Now, what actually is a halogen? And I did a video on this recently about the periodic table, and I'll link it for you. But essentially a halogen is a non-metal that's found in group 7 in the periodic table. It's in group 7 because it has 7 electrons in its outer shell, or seven valence electrons. Elements including chlorine, bromine, iodine, they are all found in the halogens in the group 7 group. So let's have a look at an example. We've got propene, which you can see as C3. So there's 3 carbons that are there. You can see the functional group, the double bond, and it tells you that it's an alkene. It reacts with chlorine, and remember, chlorine is a diatomic molecule, so it means that there are 2 atoms that are covalently bonded together. Chlorine is a non-metal, so that's why it's a covalent bond. They spontaneously react together, so there are no conditions like a catalyst or high temperature to cause these to react. They just do that spontaneously or on their own, and they form a haloalkane. So it's still an alkane because the carbon is bonded together as a covalent single bond. And what we form is one called dichloropropane. So why is it dichloro? Dichloro just tells you there are 2 chlorine atoms attached to the rest of the molecule. And at this point, it's really important to know that this is no longer a hydrocarbon, because there's actually another type of atom that's there. There's no longer just the hydrogen and the carbon. It's the same with my previous slide on hydration. Because there's an oxygen now there in the hydration example, it's no longer a hydrocarbon. So it's just being aware of those functional groups and how it changes the chemistry of things slightly. So have a go at the next question. As always, the answer will be in the description box. And that's it. Thank you so much for your time today. I've been the GCSE science teacher and you have been curious. Thank you so much, by the way, for everyone who has been really supportive of my channel and my Instagram and TikTok. I am so grateful to have so many lovely people joining this community. If you would like any specific content on biology, chemistry, or physics GCSE, specifically paper 2 stuff, I know a lot of you have asked for that, whether it's on Instagram or on TikTok, or even on YouTube as well, do let me know and I'm more than happy to create that for you. We've not got long until the GCSEs and I'm sure you are as excited as I am for those to start and you can show your amazing knowledge. If you are struggling or you know of someone who is, do share my channel with them. I'm more than happy to help where I can. So yeah, have a great day and I'll catch you in the next one. Bye.